Step-by-step exam solutions. Okay, math class, training you to excel. Subscribe, like, share, alert for the next video. Please drop your comment. It will help me to serve you better. Okay, math class, present step to exam success. Step 1, pray. Step 2, plan. Step 3, prepare. Step 4, preview. Step 5, performance. These are the 5 steps to prosper, to excel in examination. Okay, mathematics class, present step-by-step exam solution. Okay, mathematics class, present angles of elevation and depression. In this presentation, we are going to be looking at angles of elevation and depression, and we are going to study the following. Number 1, identify and define the angles of elevation. Number 2, identify and define the angle of depression. Number 3, solve problems involving angles of elevation. And finally, we're also going to solve problems involving angles of depression. So these are the things we will be studying in this present video. So the objective for this class are, number 1, to identify and define angles of elevation and depression. Number 2, solve problems involving angles of elevation and depression. Let's go into the video proper. The angle of elevation, the concept. To define the angle of elevation and depression, we need 2 important surfaces, the horizontal surface and the vertical surface, or what we refer to as horizontal plane and vertical plane. This is a vertical plane standing like a wall, and this is a horizontal plane or surface which is flat on the floor or at the ceiling. Therefore, we can say a horizontal plane is a flat surface on the ground. A vertical plane is a flat surface which stands like a straight wall. Having seen the meaning of horizontal and vertical plane surfaces, let's now define the angle of elevation. The angle of elevation. What do we mean by that? Now we have this pillar, and then at a distance, certain distance from the pillar, we have this point here. Then we have a line joining from the end here to the top here. Then we are going to be looking at this object. From this position, we'll be looking at this object. So now, this is a person looking at the object. Now, for this, we have the horizontal surface, and then we have the vertical surface. This gives us the line of sight, or direction of sight of the observer. The observer is down, looking up to see the object above. The angle with which the observer takes to observe the object above here is known as the angle of elevation. What then is the angle of elevation? The angle of elevation is the theta you can see in the diagram. Is the angle formed between the horizontal and the observer's direction of sight. That's the angle of elevation. The angle formed between the observer's side of the sight and the horizontal. Now, having defined the angle of elevation, then we are going to go straight to define the angle of depression. So we have the same diagram, but the difference here now is that we will not be looking up to see the object above, but now we will be looking down to see the object below. So now the object is at this end. Now the observer will be at this end, looking down to see this object. Now this sight, the direction of sight of this observer, makes an angle with this horizontal. So you better place the horizontal above, because depression we are looking down. So now we join from the observer's view to the object. The angle formed between the observer's view and the horizontal. This angle formed here is known as the angle of depression. That is what we call the angle of depression. Then the angle of depression is the angle shown in the diagram phi. It is the angle formed between the horizontal from the top and the observer's direction or line of sight. That is what we refer to as the angle of depression. The angle of depression is always measured from the horizontal. The angle of elevation is always measured from the horizontal. Now, we do not measure angle of depression or elevation from the vertical. Doing that is what I refer to as mathematical suicide. What's the relationship between the angle of elevation and depression? Let's look at the diagram again. Now, as already we observed, this angle here is the angle of depression. This is horizontal, and this is another horizontal. They are parallel. Angle formed between two parallel lines, or what we refer as Z angle, shown by this Z. We know that these two angles are alternate angles. It then means that the angle phi is equal to the angle theta. The angle of depression, phi, is equal to the angle of elevation, theta. The two angles are always equal. But in sketch, please always put the elevation down and depression above. That is very important. So, you know the property we use there, there are alternate angles. Now, having done with the concept, the theory of angle of elevation and depression, now let's go to the practical. Let's see how we can solve problems on angle of elevation and depression. Here we have a question. From the top of a tower, 50 meters high, the angle of elevation of an aircraft flying at a height of 1.4 kilometers from the ground level is 35 degrees. Calculate the ground distance of the aircraft from the base of the tower. Now, this is a geometry question. In every exam, Cambridge, WAEC, or any other exam you are writing, every geometry question requires diagram, and this diagram is very essential to solve this problem. Now, what are the diagrams? What is the diagram that can represent the information in this sketch? So that brings us to the solution. So now, I now first of all represent from the top of a tower 15 meters above. This is the top of the tower. This is the tower 50 meters from the ground level. Then the aircraft is flying at a height of 1,400 meters, which is 1.4 kilometers. So now, if I draw the horizontal and I also draw horizontal from the top of the tower, then I can now measure the angle of elevation of the aircraft. The position of the aircraft is here. Then I can now have this at this point. So now, the observer is looking up to see the aircraft, which is 1,400 meters above the ground. So now, this is the observer side of view from the horizontal. This angle is what we refer to as the angle of elevation. And that's the angle we're going to use in our calculation. Now, to do this, the height of the tower from the ground is 50 meters. And the height of the aircraft from the ground is 1,400 meters. We need to find the height of the aircraft from the top of the tower. That's the one that is highlighted now. We need to find that. To find that, you should know that this distance that's shown here should be 1,400 meters minus 50. So now, using this labeling, we can now going to begin to solve the problem. But before then, please like and share. Now, let's solve the problem. The height of the aircraft from the top of the tower, represented as AH, will be equal to 1,400 minus 50. If you subtract 50 from 1,400, you are going to have 1,350 meters. So measuring from the top of the tower, the aircraft is 1,350 meters above the top of the tower. Now, we need to find that, we need to use that to solve the problem we're asked to find, to calculate the ground distance, which we are going to show in the diagram. So we have tan 35 will give me the height of the tower over the ground distance, which is TH. So now the TH is not known, and that's what we are trying to find. So now we make TH the subject. Of course, you know how to make what we are looking for, the subject or the formula, cross multiply and then divide. The TH will give me 1,350 divided by tan 35 degree. So having done this, so we now go further to calculate TH. So TH will give me 1,350. Now use your calculator. Make sure that the mode of the calculator is in degree. Now find tan 35 degree. If you do that, you are going to have tan 35 degree will be 0.7002. Now using the same calculator, divide 1,350 by 0.7002. If you do that very well, the answer will give you 1,928 meters. Now that will give me 1,928 kilometers. So that means we are free to give our answer in meters and in kilometers. Since the distance given are both in meters and kilometers, so you are free to give the answer either in kilometers or meters. Then we are going to move to the next slide to continue the topic. So now example 2, and the question reads, two vertical poles are 20 meters apart. The taller pole is 25 meters high. From the top of the shorter pole, the angle of elevation on the top of the taller pole is 30 degrees. Find the height of the shorter pole. This problem is similar to the first one. So let's solve it together. So I represent the two poles. Remember, they are 20 meters apart. One is 25 meters, and then we're asked to find the height of the shorter pole, this. So now, this is the shorter pole, this is the taller pole. So the angle of elevation from the shorter pole at this point, from this level to this point here, is what is given to us. So that is giving us 30 degrees. So now this height here is 25 meters. 25 meters. While the shorter pole is not given, then they are standing 20 meters apart. 20 meters apart. The height of the shorter pole is not given, so we have that as what? X meters. Now, the angle of elevation is given. That's the angle here, and that angle is given as 30 degrees. Once again, we know the height from the top of the taller pole to the base of the taller pole, but the height of the shorter pole from the base is not given. It's represented as X. So we can easily find the distance between this point, this level, and this level. So now that will give me 25 minus X. The whole of this length is 25 minus this, giving us 25 minus X. Now using the information above, we can now start solving the problem. Tan 30 degree. Tan 30 degree will be equal to 25 minus X. So we write it and then divide by their distance apart, 20 meters. So we'll now place that 20 meters there. So now that will give us that. Then we're going to go further to simplify. Make 25 minus X the subject. So I'm going to have 25 minus X will be equal to 20 multiplied by tan 30 degree. So now I'm now going to put the value of tan 30 degree. Now use calculator. Make sure your calculator is in degree mode. Then we are going to have 20 times 30 times 30 with calculator will give us 0.5774. Check with your calculator and you discover this value is correct. So now we have the only unknown here is x. So we're going to make x the subject. But before then, let's simplify the right-hand side further. So multiplying 20 by 0.5774, we're going to have 11.548. Then make x the subject. Take x to the right-hand side and take 11.548 to the left-hand side. That will give me, x will give me 25 minus 11.458. Remember, x being negative on the right side, going to the left side becomes positive. And 11.548 being positive, moving to the left side becomes negative. That's why we're having this. So the value of x then will now give us 25 minus 11.548. That will give me 13.452 meters. The height of the shorter pool is 13.45 meters. So now that gives us the solution of that. So we now move to example number 3. Example number 3. And the questions read, the pilot of an helicopter flying at 500 meters observes a boat at an angle of depression of 10 degrees. Make a sketch to illustrate the information and calculate the horizontal distance of the boat to the helicopter correct to two significant figures. Once again, we must sketch. So now we have the boat and then the pilot is flying at that height. And the pilot is, the helicopter is 500 meters above the ground. So now this is the ground level measured from the level of the helicopter. So now we now draw the line of sight, direction of sight of the pilot to the boat. Then we complete the horizontal from the ground level, the sea level. Now, remember we are told that the angle of depression is 10 degrees. So we represent that. That is the angle of depression given in the question. Now, the question says we should calculate to two significant figures the distance of the aircraft from the horizontal level. So that's the distance we're asked to calculate. And remember, this is 90 degrees. We have that. Now, highlighting this, that's the triangle we're going to use in our calculation. Then we're going to use the property that says that the angle of depression is always equal to the angle of elevation. So we need this angle to be at this point. So we use that property of alternate angles to know that this angle is equal to 10 degrees. Then applying this, we know this. We don't know this. This is also given. We're now going to have tan 10 degrees will be equal to 500 here. This 500 divided by the horizontal distance. That's the horizontal distance. So now, simplifying that out, making the unknown the subject. So we're going to have h will be equal to 500 divided by tan 10 degrees. So 500 divided by tan 10 degrees. So we go further to find the value of h. So h will give us 500. Now we use calculator. Measure the mode of the calculator is in degree. Now find tan 10. Find tan 10. If you use calculator and make sure that the mode is in degree, the answer you get is 0.1763. Then we write it here, 0.1763. So now, using the same calculator, we now divide 500 by 0.1763. So the h will give me 2,836.07 meters. But remember, we are asked to calculate the the horizontal distance correct to two significant figures. Now we're going to round up this to two significant figures. Doing that, we're going to have the final answer as 2,800 meters, correct to two significant figures. We now go to example number 4. Example number 4. The pilot of an helicopter flying at a height of 800 meters above the ground, observe the angles of depression of the top and base of a tower as 20 degree and 25 degree respectively. Calculate 1. The height of the tower. 2. The horizontal distance of the helicopter from the base of the tower. Correct to 3 significant figures. As usual, you already know that the first step is to make a sketch of this diagram, because there's no point wasting your time solving the problem that you not earn any mark in any external exam because you did not draw the diagram. So let's sketch the diagram. So now we have the helicopter flying at a height of 800 meters. Then we have the horizontal distance of the tower. This is the top of the tower and this is the base of the tower. Therefore, the height of the tower is now represented as h. Remember, you can use any letter of your choice. So from the top, or from the pilot of this helicopter will observe the top, the angle of depression of the top, and also the angle of depression of the base. So the angle of depression of the top, we are told is 20 degree. So now we represent that. That's the angle of depression of the top of the tower. Then the angle of depression of the base of the tower, the base is 25 degree. And then we also represent that. That is 25 degree. So now that is 25 degree. You can see it in red. So now, using also the property of, or the relationship between the angle of depression and angle of elevation, which we know they are alternate angles. So we can transfer this 25 degree to this place. Then we're going to have that as 25 degree. So with this diagram done, we are now ready to solve the problem. The first question says we should find the height of the tower. Please take note, there are so many methods you can use to solve this problem. You can use sine rule or cosine rule. You can use trig ratios and so many other methods. So the method I'm using now to solve it is not the only method. Please take note of that. Time will not permit us to show all the methods in this particular video. So now let's now solve the problem. So we have, looking at the triangle that is highlighted now, we are going to use that to solve the problem. So now, tan 25 will give us 800 divided by the horizontal distance, x. Looking at this, the only unknown there is what? X. So we make x there subject by cross multiplying and dividing by tan 25. So x will give me 800 divided by tan 25. Then going further to solve and get the value of s will be equal to 800. Then use your calculator. Make sure the mode of the calculator is in degree. Find tan 25 degree. If you have done that, the answer you get to 4 digits will be 0.4663. So we write that here, 0.4663. Then use the same calculator, divide 800 by 0.4663. So x will give us 1,715.6 meters. We'll write that in this place, 1,715.6 meters. And remember, we're asked to give our answer correct to 3 significant figures. So that will give me 1,720 meters, correct to 3 significant figures. So now I've gotten the height of the tower. The next question says we should find the horizontal distance of the helicopter from the base of the tower. So we'll move to the next slide to solve that. So we'll move to the next slide to solve that. So now we continue our solution here now. So now that's the diagram. Then I highlight the triangle that we are going to use to find that. The triangle that is highlighted in blue is the one that we are going to use. So now, using that triangle, we're now going to go further to solve this problem. Now, this height is 800 minus this is 800, and this is h. So that will give us 800 minus 8, as already explained in the previous solutions we had. So now, this highlighted side now is what we're going to use. So we're going to have tan 20 degree will give us 800 minus h over the horizontal distance, which is 1,715.6. Please take note, we do not use the approximated answer, the rounded answer, to continue in our calculation. We must use the original answer before rounding up. So we have this. So now x will give us 800 minus h over this, tan 20. Now, already we have calculated the value of h, so we are going to make direct substitution there. Okay, so that's what we're actually looking for. So we have that. That's tan 20. Tan 20, I believe you understand from what we have done before. So now, cross multiplying, we have this will be equal to this times this, cross multiplying. So we have that. Good. So we are going to simplify this. Use calculator, multiply this, and write the answer here. You are going to have the answer as 624.4784. Then we make h the subject. By taking h the other side, it becomes plus. Then that will be equal. Then we take this to the right, to the left side, it becomes minus 800 minus this. Then use your calculator. That's a simple subtraction. Then subtract. You are going to have the answer as 175.5216. So the value of h then will now give us 176 meters, correct to 3 significant figures. 5 here is, once the digit after the third number is 5 or above, you round up and add 1 to it. That's how we got 176 meters. So now, please subscribe, like, share, alert for the next video. Then we're now going to solve the next question. Now, the question says, a hunter aimed at a bird on a tree top at an angle of elevation of 28. He walked 12 meters towards the tree and noticed that the angle of elevation is now 36. Calculate, correct to 3 significant figures, the height of the tree. How far the tree is from the hunter the first time he aimed at the bird. Once again, we are going to solve this problem, and then we'll make a sketch. Now, that's the sketch. So from there we draw. Remember, the hunter is here, and then the angle of the elevation is 28. And then he moved 12 meters towards the tree, moving from H to the position K. Now he now observed another angle of depression to be what? 36. So now we're going to represent those angles 28 and 36. So now, the question now says we should calculate, correct to 3 significant figures, the height of the tree. So now let's solve the problem now. Let's label those sides. This is the distance of the hunter from the new position. And then this is the height of the tree. So now let's see how to solve. Using this highlighted triangle, we can find the write an equation that connects x and h. So we are going to have tan 36 will give me the height h divided by the horizontal distance, which is x. So now that means h will give me x times 36 degrees. That's equation 1. Then we are going to get equation 2. Using the bigger triangle, which I highlight now, the bigger triangle, all in red, and the angle of elevation there is 28 degrees. So we're going to form another equation. Then 28 will be equal to h over x, 12 plus x. 12 from here to here is 12. Then plus from here to here, which is x. That's the whole distance, hb. So hb is 12 plus x. Then make h the subject of the formula. So we are going to have the h will be equal to 12 plus x multiplied by tan 28 degrees. So we are going to move to the next slide to finish solving the problem. On the next slide now, we continue the solution. X times 36 will be equal to 12 plus x tan 28. Remember the previous equation we have. You can go back and check. Both equations are expressed in terms of h. So h is equal to h. So therefore, the first h, x times 36, will be equal to the second h, 12 plus x times 28 degrees. So now, we're now going to simplify by distributing tan 28 between 12 and x. So let's distribute. That will give me x tan 28 plus 12 tan 28. Remember, when you distribute, you share between those numbers or those terms inside the bracket. You should not leave anyone. So having done this, we are going to collect all the terms in x. So that will give me x tan 36 minus x tan 28, bringing x tan 28 to the left side, it becomes minus, and that will be equal to 12 tan 28, the term without x, to the right, while the term with x to the left. Then there is a common factor here. X is common to these two terms. So we are going to bring that out. So we are going to have this will be equal to the term without x. So now we are going to make x the subject. That will give me this tan 1228 degree divided by the whole of this we have here. And what is that? Tan 36 minus tan 28. So we write it here. Then we simplify. So x will give me that, putting in the value of tan 28 and tan 36. So x will give us, the numerator will give us 6.384. The denominator will give us 0.1948. Use your calculator to divide this. You are going to have your answer to be 32.75 meters. Then x, rounded up to 3 significant figures, will give me 32.8 meters. 32.8 meters. 32.8 meters. Please, it's not 32.6. 32.8 meters. Good. So now we're going to find the value of h. Using the value of equation we already have for h, we have x times 36. So we now put the value of that. Remember, we don't use a rounded up answer, we use the original answer. Times 36 degree, already we know the value as 0.7263. Sorry. Then use calculator, we multiply this. So we're going to have our answer as 23.792875 meters. Then round that up to 3 significant figures. That will give me 23.8 meters, correct to 3 significant figures. Then the last question for this presentation. Now, 2 friends, Albert and Barry, went towards a tall mast from the opposite side. When they are 12 meters apart, Albert measured the angle of elevation of the top of the mast as 30, while the second person measured the angle of elevation of the top of the mast as 45. Calculate correct to the nearest whole number the height of the mast. How far from the mast base is Barry? So now let's solve this question now. So we have the mast. The two friends, one is on the left and the other one is to the right. So now we look at that. The angle of elevation here is giving us 45, while this one is giving us 30. Then the distance between them is 85 meters. The distance between them is 85 meters. So we have that. Sorry, the distance between them is 12 meters. It's not 85, it's 12 meters. So if this side is x, this side will be what? 12 minus x, because the distance given is 12 meters and not what I mistakenly put here, 85, is 12. So now we're going to take this side, and this is 45, this is 90, then this angle is 45. It then means that the h is equal to x, because this triangle is what? A right angle isosceles triangle. So h is equal to x. So now, using the other side of the triangle, we can now find the value of x and h. So now let's now get that. Tan 30 degree will give me h over, will give me h over 12 minus x. Now, remember that h is equal to x, so we can actually replace any of them. So that will give me x over 12 minus x. Remember, h is equal to x. That's why I replace h here by what? X. So now, having done that, we'll move to the next slide for the final solution. So we have this. Tan 30 degree will give me x over 12 minus x. So now we put in the value of tan 30 degree as 0.5774. And that will give me x over 12 minus x. We'll cross multiply. We have x will give me 0.5774 into 12 minus x. Then we distribute this. Then we are going to have this times 12 minus 0.574x. Then we collect the terms in x together. The minus going to the left side becomes plus, is equal to what we have here, 12 times this. Then we add. That will give us that. Then we now make x the subject. We have 0.69288 divided by that. Then simplifying further, that will give me the numerator divided by the sum of the denominator. Now use your calculator. Divide 6.9288 by 1.5774. If you do that, you are going to find the value of x will be 4.3925 meters. 4.3925 meters. Then rounding it up to 3 significant figures will give me 4 meters. Rounding it up will give us 4 meters. And therefore, the h also will give me 4 meters. That brings us to the end of this presentation. Please remember to subscribe, like, share, and click for alert so that when the next video is released, you will be informed. Thank you for watching.